In today's A-level and IB chemistry video, we're going to be looking at the degree of unsaturation or index of hydrogen deficiency. Now, why are we even interested in doing this? It allows us to determine from a molecular formula the number of rings or multiple bonds in a molecule. Now, remember that carbons can have 4 bonds, so the most number of hydrogens it could possibly have is 4. But the moment you introduce double bonds, triple bonds, arrange carbon in a ring, then you're not going to max out on the number of hydrogens that there are. And we call these missing hydrogens effectively a hydrogen deficiency or a degree of unsaturation. And so effectively here you're trying to work out the degree at which the hydrogens are missing. So by calculating the degree of unsaturation or the index of hydrogen deficiency, we can calculate the number of rings or pi bonds present in a structure. So notice that a double bond is 1 hydrogen deficiency, a triple bond is 2, a ring is just 1 hydrogen deficiency, an aromatic ring is 4. I'm now going to show you a formula which can be used to find out the degree of unsaturation or the index of hydrogen deficiency, and then show you how we can use that to work out the structure. Now, there are lots of different ways you can do this, but the one I'm going to teach you is my favourite way, which is using an expression. And this states that the index of hydrogen deficiency is given by 0.5 multiplied by 2c plus 2 minus h minus x plus n. Now, I know this might seem a pain to learn off by heart, but it's one of these things that if you learn it off by heart, it works every single time. And in this way, you can make sure you always get the answer right. Let's identify what these letters mean. So C stands for the number of carbon atoms. H stands for the number of hydrogen atoms. X stands for the number of halogen atoms. Doesn't matter which halogen we're talking about, but we're looking at group 7. And N stands for the number of nitrogens. So if we take an example, we'll see that this always works. Find the index hydrogen deficiency for C4H8O2. So let's identify what we have. Well, we have 4 carbons, 8 hydrogens, no halogens, and no nitrogens. So subbing it into that formula, we do 0.5 multiplied by 2 lots of carbon, so 2 times 4, plus 2 minus 8 hydrogens, minus 0 halogens, plus 0 nitrogens. So then we need to sort out that bracket. So 2 times 4 is 8, plus 2 is 10, minus 8 equals 2, and 0.5 times 2 is 1. So the index hydrogen deficiency here is 1, and therefore we can infer that the molecule contains either 1 double bond or 1 ring. So now we're being asked to find the index of hydrogen deficiency for C2H2. So we'll identify the number of carbons is 2, the number of hydrogens is 2, using the formula. So 2 lots of carbon is 2 times 2, plus 2, minus 2 because we have 2 hydrogens. We don't have any halogens, we don't have any nitrogens. Sort out that bracket. 4 plus 2 is 6, minus 2 is 4. So we have an index of hydrogen deficiency of 2. And looking up, we know that a triple bond has a hydrogen deficiency of 2. So this molecule is likely to contain a triple bond. And it is in fact ethyne, which looks like this. So there's the triple bond. So now we're going to find the IHD for aspirin. So what do we have here? So I'll write out the formula again. So how many carbons do we have? Let's use the highlighter. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. The number of hydrogens is 1, 2, 3, 4, 5, 6, 7, 8. We don't have any halogens and we don't have any nitrogens. So 2 times 9 is 18, plus 2 minus 8 for the hydrogens. Sort out that bracket. 18 plus 2 is 20, minus 8 is 12. So therefore, the hydrogen deficiency is 6 and aspirin has 1 ring and 5 double bonds. So now we're going to find the hydrogen deficiency for this complicated compound. Don't worry though, it's all the same. Here's our formula. Our number of carbons is 15. Number of hydrogens is 10. Our halogens is chlorine here, so that's 1. Nitrogen is 3 and we don't count oxygen. So more to sort out in this bracket. 2 times 15 is 30, plus 2 is 32, minus 10 is 22, minus 1 is 21, plus 3 is 24. So that is a hydrogen deficiency of 12.